Ladies and gentlemen, coders of all ages, please gather around as we gear up for the ultimate battle of programming prowess. In the blue corner, we have C#, the heavyweight champion, the backbone of enterprise software, the tool that has powered millions of applications.
But wait, in the red corner enters F#, functional maverick. With its concise syntax, immutable data structures, and mathematical elegance, it has been making waves and winning hearts.
My name is Maxim Arshinov. Currently, I'm shaping solutions as an architect at EPAM Spain. And what can I say about C# and F#? Frankly, I love both of them. However, F# has never been my primary tool, and I doubt that it can become one someday.
My name is Vagif Abilov. I come from Oslo, Norway. I work for a company, Miles. I'm so old that I even programmed Fortran using punch cards in university. But last years, I've been using functional programming and F# in particular. And I choose F# because of its expression-based syntax, as opposed to statement-based syntax of C#, immutability by default, algebraic data types, and last but not least, computation expressions.
And I choose C# because of three factors. First of all, it's a mainstream, feature-rich language. Secondly, it's extremely versatile. And last but not least, again, I lack convincing arguments to replace C# with something else.
So C# and F# are going to battle for your votes. Both are .NET languages. Both are pragmatic. And actually, both position themselves as multi-paradigm. C# has evolved quite a lot into functional direction, adopting functional concepts. And F#, it hasn't changed so much since it was introduced in 2005, but from the very beginning it supported programming in OO, object-oriented.
Let's consider strengths and weaknesses of each language without bias. So please consider the merits of each language based on our discussion today, rather than your personal preferences. By the end of the talk, we'll be able to identify the winner, and you are going to be the judges today. So, before we start our first round, let's check that the voting procedure works as expected. Who are you? Are you a C# person, F# person, or none of the above? Oh, it's so cool. You know what to do.
Okay, does voting work? Okay. Oh, I see I'm already in a vast minority. I hope you will be fair judges. 90 to, oh.
Yeah,
okay, we still have some, none of the above, so it's just C# and F#. So yeah, okay. Only .NET folks here.
Yeah, this QR code will be available on each slide. So, and you don't need it actually. The screen should be updating automatically. But in case it's not, the QR code will be there. So round one, type systems. We are going to compare the difference between type systems of C# and F#. C# is an OOP first language, and it's quite natural to use classes and interfaces to the main business logic in C#.
And F# is a functional language, so it uses algebraic data types, which consists of product types and sum types. And product types are similar in both languages. It's classes, it's structs, it's records. So we'll focus in this comparison on sum types, which combine mutually exclusive cases.
Okay, but interfaces first. We are going to be using the e-commerce domain throughout our presentation, mostly because we presume that most of the people here are familiar with this domain, either as developers or as consumers. So these kind of systems usually have some notification capabilities, and to trigger the notifications, I would introduce an interface like iDomain event, so that I can create classes like order placed, order paid, order shipped. So these are arguably quite simple classes, and they all implement the same interface.
And this code looks quite familiar to me. This is how I was writing events. Back in the days, I was using C#. But today, it looks a bit verbose. Like everything needs to implement interface. Then you have, of course, accessors. You need to specify visibility of methods, and you have constructors. So, in comparison with F#, I think it's too much of details.
If syntax really bothers you that much, I think that we can kind of work around the situation. Since C#9, we can replace classes with records, so it's arguably cleaner and simpler.
Yeah, actually, this looks very much like it's in F#. C# people always getting best things from F#. I'm a bit jealous here.
Yeah, we stole this feature from F#, true.
Yeah, but yeah, it still has this interface. So in F# it will be slightly differently.
Okay.
So what are events? Like events are one-off. So it's typical sum type. It's so-called discriminated union. And so you first define your payload, your types, and then you group them together.
Okay. I have a question here. So when I look at the event payload type, it looks like it is effectively closed for both modification and extension, because each time I want to introduce a new event, I need to modify the event payload type. And I'm starting to think about the open-close principle that states that entities should be closed for modification but open for extension. And this program entity is closed for both modification and extension. So this looks like a downside to me.
Actually, it's a principal difference, and it's good that you brought it. Because yes, if you developing a public class library, then I guess interfaces is the way to go. But more often than not, the team owns the whole code base, and I think that the full choice of having this close grouped sum types, it gives you better programming experience.
Really? And what is better?
For example, exhaustive pattern matching. Like if you look at, yeah, here we have match payload, and then if you don't match all cases, you can get compiler warning on even error. So compiler knows what are the union types.
Okay. I'm not sure if I'm convinced. What I see here is yet another way of doing quite the same thing. It's not necessarily worse, but I don't see if it's better. Yes, it's different for sure, more functional, absolutely, but, well, kind of meh.
I'll try to give you proof that C# folks actually need union, because there is a open source library one-off. It's a NuGet package with almost 14 million downloads, which tries to simulate union in C#. So definitely the request from developers is there.
Yeah. So since we don't have discriminated unions, we have to emulate them. And instead we use classes, and we don't have exhausting pattern matching in C#, so again we have to emulate it. But I'm quite happy with this emulation.
Yeah, one-off helps, but it's not full replacement of for discriminated union, and has its downside. It supports only up to 31 case. It's pretty many code lines which generate internally. So I'm not really convinced. It's a hack.
Well, fair enough. Yeah, it is. So maybe that's kind of feature that is best implemented as a part of a language rather than a third-party library. Yeah, but discriminated unions are actually coming to C#. So I think that the first time we grasped this concept was C#7, since pattern matching was introduced in C#, and discriminated unions were originally scheduled for C#10.
And then 11, 12, and when it be 20?
Well, it's good to have Matt Storgerson here. He told me that it's C#14-ish plus.
Okay. Promising. Well, then we'll have another vote. But today we are where we are.
The first one.
The first round,
first one to count. So, does discriminated union enrich language type system? Like super heavy? Yes, point to F sharp. No, point to C sharp. Okay, let's see.
Oh.
It's pretty close.
Oh. Oh.
Wow. Quite unexpected.
Oh.
Okay.
Should we vote 2? No, we are 1-1. Okay. Let's close the vote. Let's close the vote.
Okay.
Okay.
So 1 point to C sharp, but it was pretty close.
It was pretty close.
Yes.
Much closer than I thought.
We have to speed up a little bit.
Yeah.
So round 2, data model and operations. What do we see here? Oh, yeah.
Well, let me begin here. You see, this is how I was doing C# in the beginning, and this is probably how they teach C# in university. Like you have an order, you have some data, you have some methods. But later, I drifted towards a different implementation, which, if you show us the right-hand side, then we'll see different implementation. Like you have class order, which is just pure data, and you have some sort of order manager, which handles all operations for it. And then I think that there are two different schools in C# community, and which can actually confuse people, especially if like senior developers with strong opinions work on the same project.
I don't think that the fact that C# provides multiple ways of doing things necessarily a bad thing. It just caters to a wider variety of programming options and preferences.
Well, but isn't variety a problem here? Especially when there are such strong opinions from technology leaders in the field?
Like Martin Fowler. Well, kinda, oh, sorry. Let me get back. Yeah, kinda, yes, no, because on one hand, yes, there is some confusion. On the other hand, maybe it's more a matter of your religion. You just choose one and then you stick with it, trying to do your best to avoid any blasphemy. Yeah, you need to choose once.
Mm-hmm. Well, I think with functional programming, you get better default and you get sort of one default. That you have your data structures, you have your operations, and I wholeheartedly agree with Slade your answering that this is something to follow.
And how does thing look like in F#?
Yeah, so you see on the left-hand side, this is how you define your data. In this particular case, it's a sum type, discriminated union, and then you have operations. Typically, we have them in the modules, and then you build your order processing pipeline in this model program, as you see, where we call operation that use those data.
Yeah, but there's something I don't see here, like dependencies, database calls, third-party services, perhaps. Aren't you oversimplifying this example?
Yes and no. Yes, of course, you will need to bootstrap this and send some dependencies, so you can do external services and call to databases, but it will not change the picture, and it will not change the order processing pipeline structure. It will be the same.
Okay, I'll believe it. We are close to the next voting session, so I still think that the versatility of C# is not a weakness, it's a strength, and it's okay that we have multiple ways of doing things.
Yeah, and I think with F# you get more clarity, and it prevents you from some logical mistakes when you have this clear separation between data and operations.
Shall we vote then?
Yes.
Data structures and functions should be bound together or should be completely separate? Okay.
And?
Okay, F# is getting ahead. Let's wait maybe additional 20 seconds. It looks like...
Interesting.
Yeah, it looks like that we have a clear winner here.
I didn't expect that, I must say.
Yeah, I didn't see it coming, right?
Okay.
Yeah, it's 1-1, right?
Tough round.
Tough round. Round 3, polymorphism versus pattern matching. So our aim here is to compare well-known techniques that both have help make code more expressive and maintainable, but they're quite different. In C#, it's quite common to define an interface so that it is possible to create additional classes like card payment and bank payment, but I don't need to know the implementation detail of each payment option. What I need to know is that they both implement the same interface, so I would use the interface link.
So the main idea that you sort of generalize operations, you do it on iPayment without knowing concrete classes, right?
Yeah, I think that's the definition of polymorphism.
Mm-hmm. And there is some principle, I think, in OP, which is it Liskov that validates?
Yeah, LSP, Liskov substitution principle. Yeah, it states that we can replace superclasses with subclasses without ruining our program.
Yeah, and Liskov substitution principle, it really helps you to validate that if you have truly polymorphic class hierarchy. But I believe that in this competition on my side, because in my experience, developers violate it all the time. Like here, if there is a new type which we just introduced, cash payment, which supports new scenario, payment on delivery, and then we need to change our processing method. So order used to be able to pack for delivery if the payment is completed, but in case it will be paid on delivery, then we can check it at sort of right here, check on the type, and then proceed with order delivery. Doesn't validate Liskov here.
But I mean, you don't have to do this, right? You could have introduced another interface, or you could have extended the original interface. I think that you deliberately just created an example that plays.
Yes, I did it on purpose, of course. But this is actually my experience, that every time you realize that Word is slightly more complicated, you end up changing your abstractions, not concrete classes, but abstractions, and using virtual methods, interfaces. I find this process to be tedious.
Okay, so how do you do it in F#?
With F#, first of all, the definition goes in opposite direction.
Like what?
You start with concrete classes, like card details, bank account, and then you group them in here, like in discriminated union funding source. So actually, the concrete types, they stay unchanged. They are not aware of their grouping, actually. And then you can pattern much later on this funding source.
So it's kind of bottom up instead of up bottom, right?
Yeah, you can say that, yes. Yeah, so this is F# implementation where you basically pattern match on funding source, and then you do different things for cash payment.
But I mean, it's the same thing. You are violating LSP as well here.
Well, there is no LSP applicable here because we don't have this class hierarchy. We don't have this abstraction. So in functional programming, there is respect for polymorphism, but usually it's parametric polymorphism. When you send generic input to a function, then LSP fully applies. But here we're talking about like subtype polymorphism, and I'm afraid the real world is more often than not just not truly polymorphic. So this is more fair.
Clever enough. You cannot violate polymorphism if you don't use polymorphism.
And to strengthen a little bit my point, I want to give you this example. And this is not something we deliberately wrote to look bad. This is one of the oldest .NET class. It's a stream, and it's polymorphic, everything sort of abstract and virtual. And then, unless you see that this can read, can see, can write, so actually every essential method can throw exceptions. So yeah, you have a lot of polymorphism defined here, but where does it go when every method throws exception?
Yeah, that's a mess. And that's not the only class. Queryable, collections. At least if these classes were implemented today, I think that they would have been implemented quite differently.
Yeah, probably. But I just want to point out that things can go wrong if you first need to define abstraction, and then you're bound to that, and then such things may happen.
Yes, I agree. So these are just two different options, and we really need your help to understand which one is better here.
Yeah, that should be a tough one. I mean, C# people, how do you program? You have very fair judges, but you sort of vote for features that sort of not natively...
We are aware of solid.
Yeah. But we have people who actually came at 8:30. They're explorers, they're early birds, they're open for challenges.
Yeah.
I mean, I really appreciate that.
2-1, right? 2-1.
Okay.
Let's continue. So, round number 4, error handling. So we've already seen some exceptions thrown from the stream class, so it's about time to discuss error handling. Throwing exceptions is de facto standard of dealing with errors in C#. Actually, that's a best practice from Microsoft, but I have to admit that that's not the only way of dealing with errors in C#, but we'll come into it a bit later.
So this is a slide from the excellent talk by Scott Flashen, Railway-Oriented Programming. And it shows that developers really learned well that they should be using exceptions and not error codes. Don't you think, Max, that one problem has turned into another?
No, I think that that's the same problem, and it has nothing to do with either error codes or exceptions. I believe that the real problem is that error handling is A, boring, B, tedious. People just don't want to bother with this kind of stuff. And the real problem is the human nature. We really need to pay more attention to the requirement management, especially in terms of what can possibly go wrong here.
Mm-hmm. So it's a question of discipline.
Yes.
But I also think that there's a problem with exceptions that really complicate execution flow. Even if you have just single exception, like here, you have one line of happy path surrounded with 7 lines of exception handling. And this is just one exception. If you need to catch several, then error handling just quickly become overwhelming. And also, how do you recover, like if you have an exception from database collection? If you have multiple threads like here, what you do if you caught exception in different thread? So it's really getting bad in terms of code management.
If you ask me, I would rather use global exception handling instead. So Poly is the library that is coming to my mind immediately. You don't have to copy-paste, try-catch blocks across your entire code base. Instead, you can configure like generic global global things to make sure that you know how to recover from different exception types. And you only need to do it once on the startup, right?
Yeah, I've checked Poly. It's a great library, and definitely it's interesting to explore that. But I believe that we are here to analyze like language intrinsic capabilities, like native handling of errors. So let's not bring add-on libraries here. Just focus on native things.
Well, I would consider the language and its ecosystem as a whole. But you know what? Let's continue. I just would like to see where you are getting at.
Yeah, first I just need to sort of state for the record that exception handling consider it harmful even just by people practicing object-oriented programming. But of course for statement-based language like C#, there is no way back to errors. Within F#, everything needs to return something. And so we have a result in F#, which is some type, which is committed union, which turns either some OK or error, and you can match on the result. And since F# is expression-based, and then you can't just forget to check the error. You should either actively ignore it, or you'll get compiler error.
I think that this piece of code is beautiful, but what if I needed to combine several responses together? Like this single pattern matching is okay, but when I have like result plus result plus result, would I need to write this pyramid of doom sort of code?
Yeah, without going into too like low-level details, of course you don't need to write such horrible code. You can write some auxiliary, some helper functions to work around that. So if you go to next slide, so you have this bind function which can bind results and functional input, and then you can use this function and define another operator which looks like a fish. Yeah, and you apply this operator in your order processing pipeline. And then you, on the left-hand side, it's this order processing pipeline with fish operator, which looks almost identical to the original pipeline, but which is error-aware. So actually, it handles all these nitty-gritty details of what can go wrong, and if it's an error, what should I do? So we can use that.
Well, I propose we postpone the discussion of these mysterious operators of yours until the next round, and for now, we can vote. Is it exceptions plus try pattern? And that's the other way of doing error handling in C#. I think you all are aware of this. Try pass, Boolean, true, false, out parameters, thing like that, versus result type plus exceptions. And yeah, by the way, we still need the exceptions in F# because of the ecosystem, right?
Yeah, of course, you can also throw exceptions in F#, because, yeah, it's .NET language after all. Mm-hmm.
Yeah, we can take this offline. I think this discussion worth yet another talk, like, do we need checked exceptions?
Okay, so it's close. With some...
I didn't see it coming. Why do people dislike the exceptions so much?
We have exceptional audience here.
Exceptional audience.
Yeah.
Okay, is it 2 versus 2 right now?
No, it's 4 versus 0.
Oh.
And we have only 2 rounds, by the way.
We are even, yeah. Until now, we've been discussing similar techniques, and this round is quite unique because we are going to present a unique F# feature. Let's check something. How many of you are familiar with computation expressions in F#? Please raise your hand. Quite a few.
Very few.
Yeah, okay. Vagif, would you mind introducing computation expressions, please?
Yeah, just very briefly. So instead of using that fancy operators, which we just saw in previous round, we can actually look at more like native in sort of, and this is order processing pipeline that uses result computation expressions. It has this not just let, which assigns, which create value. It has this let bank, which basically means let with some additional semantics. And this additional semantics is defined in this by this result computation expression. It's in blue, so it looks like a keyword, but actually this is not a keyword in the language. You can extend language with additional things like result, and you can then attach some additional semantics on F# operators, so it will do all internal things for you.
So in other words, a let bang is just a shorthand for the bind function.
Yeah.
Which in turn is a function that can overcharge other functions in a way that is possible for them to work with wrapped values.
Yeah, and good thing that you basically don't need to know about it.
Yes, I think that it's kind of similar to how async await works in C#.
Yeah, exactly. And this is async in F#. And then, so you see, we have different computation expression, async, and then let plays different role. It works just like await in C#. Actually, if you replace this let bank with like var and await, you almost get C# code.
Yeah, let's compare it with C#. It looks very similar, but this version is specialized. And yeah, there's an important difference. Await is a keyword here.
Yeah, that's a big difference.
Yeah, that's because C# is a statement-based language, while F# is an expression-based language.
Mats Orgerson said yesterday, so that one of the reasons it's imperative language, so they couldn't do sort of another way. So it's extended using keywords. But in F#, you don't need to implement keywords in the language. You need to upgrade language. So this is another computation expression, query, which does different things, and also you can have many more. So these are just incomplete list of available computation expressions, either from a F# core library or some open source libraries, like we in our project use a lot actor expression, and then you can write your own.
And I am uncertain about this. On one hand, computation expressions is truly maybe the only F# feature that I lack in C#. On the other hand, computation expression is just a flirty way to say monad comprehension. And everybody knows that monads are evil, confusing, and stuff like that. So for a language like C#, which is a mainstream language which should be beginner-friendly, I'm not sure that we need a tool that is such powerful, and more importantly, that has something to do with monads.
Well, you said word monad. I didn't.
You said word bind.
Yeah, I don't like threatening people, because somebody said that like nobody understands monads. It's sort of monadic computation expressions, but again, you don't need to know all the internals. You can use them. If you want to write your own computation expressions, yes, you need to learn some more, but it's your choice. So I still find it pretty elegant that there are in F#.
I can say the same thing about C#. You don't need to know the internals of async await or link or yield to work with all of them. And these keywords are quite sufficient. And maybe that's a good thing that we don't have a generic concept. We rather have multiple tools that do exactly one thing, but do it great. So I think that this approach is potent and perfectly viable.
Mm-hmm. Yeah, so you see there are very different ways they approach like extending language, and we let audience vote which one is better.
Would you prefer a generic but potentially dangerous concept such as computation expression, or would you prefer to have many keywords that slowly are making C++ 2.0 from C#?
Oh, interesting. So actually, this makes a C# clear winner. It is because you said monad.
Yeah, it was my plan.
Okay, interesting. Very interesting results. So let's go to our final round.
Yeah, I would have voted differently actually, because I really like computation expressions. But anyways, so what really bothers me about C#, on this screen you can see the results of the most recent Stack Overflow developer survey. And here we can see a huge gap between popularities of these languages. And that's a gap to be reckoned with.
Well, yes, there is a huge gap. I must admit that. But before we address that, why is it important? Like you do your project in that language. Why is it important? I mean, how popular is it?
Maybe that's my internal manager speaking, but if I need to find a replacement for a key developer on the project, it's not important why. Hiring a good engineer is a challenging task in itself. When you have additional constraints, like you have to find a good engineer and this engineer has to be familiar with F#, this task automatically becomes even more complex.
Yeah, I see your point. What we experience that we don't try to hire F# people. We try to find just good developers. And mostly we actually just work people without F# experience. Once we even got a developer with no F# or C# or .NET or even Windows experience, and he became great developer in F#. Because yes, you get fewer applications, but maybe you get stronger applications, and you get people with passion who would love to learn something new.
So you don't think that's a valid concern, don't you?
I wish F# community was larger. I agree with that.
Okay. So let's check then. Is it a valid concern? Is it something that should affect our decisions?
That's a very, very interesting round. I'm really thrilled to know sort of how crucial it is to have large community. Yeah, people.
Okay.
Oh, so it's changing. Yeah. Yeah, but I guess it's fair enough.
Let's give a chance. Let's give a chance. It's getting slightly better. Mm-hmm. Not enough.
Yeah, I think C# will be winning.
This
here.
is it. Okay, so 4 against 2, and we have our win today. We should stay with C#. No, it is not the takeaway we would like to have today. And both languages, C# and F# are great languages. And there are many teams who have chosen either C# or F#, and they are happy with their decisions.
Yeah, I think what we really try to do with this short competition is to provoke some thoughts and to let you explore capabilities of the language you work with, but also to explore opportunities around. Like yesterday, we had this great talk from Mats Torgersen, and then he was specifically talking about functional features of C#, and then one of the outcomes of his talk was really explore it, learn it.
And we really appreciate your activity and your votes today. Thank you for being so impartial judges.
Yeah, thank you for being fair judges, and good luck, and enjoy the rest of the conference.
Happy coding.
Surprisingly, we still have time for maybe 1 question or 2 questions.
Do we?
Yeah, if there are questions, any questions? Yeah, please.
So how the actual code calling database would look like in F#? Because in Haskell it will be a crazy combination with IO monad and lots of different stuff.
Yeah, Haskell is a pure functional language where you can't really bring any side effect into functions. F# is more opportunistic, I would say, and it was deliberately designed this way. So you can program with side effects in F#, and typically you would sort of bootstrap these things, and so it will not. This database calls would not look very much different, actually, comparing to how you would do it in C# and Java. But yes, there is a difference between F# and languages like Haskell, where you would need to go the full path towards IO monads.
Yes, please.
Is link a monad?
A link itself, no, it is not, but it has some monadic nature.
Select many actually is close.
Yeah, I think that there is a good way to answer this question. Select, the real name of select is map, and the real name of select many is it's bind. Yeah.
Yeah. So it's a kind of it's going that direction. Yeah.
Yeah, we removed some stuff from the presentation that you can override, like get awaiter in C# to have monad comprehensions written in async await, just because it's bizarre. And you can use link to write even more weird syntax, like from any kind of stuff for which the select many function is overridden. That's actually how the C# compilers understand that it can apply the link syntax. Just the existence of the extension method with the proper select many signature is enough. But I mean, people don't do it, and don't do it in production.
Yeah.
People would not appreciate that.
Okay, I think we are. We're out of time, and next session starts in 10 minutes. So we are here. You come to us and ask us if you have more questions, and thank you very much for your early participation.